Hey guys, welcome back. So in this video, we're going to be working with the seventh Leetcode problem, and this is reversing an integer. And so it's pretty self-explanatory. All we want to do is if we're given a number like 123, we want to reverse the input and return an output of 321. If it's a negative number, we just want, if it's negative 123, return negative 321. If it's 120, return 21. And so there is one case over here which says, assume we're only dealing with, we can only store integers within the 32-bit signed integer range, so this range right here. And so we'll handle for that at the end. So what we're gonna do is I've copied the problem here, and now what we're gonna do is the first thing I'm going to do is check if the number is negative, because for now what I want to do is even if the number is negative, I want to convert it to positive so we can handle all the numbers the same, and then at the very end I can multiply by -1 if I need to. So what I'm gonna say is if x is less than 0 is negative is equal to true with a capital T, and then we'll multiply x times -1 else is negative is equal to false. The next thing I want to do, I'm going to create a variable called output. You can call this anything you want, reverse anything. I'm just going to call it output. I'll make that equal to 0. And now I'm going to say while x is greater than 0, what I want to do is I want to keep adding on to the output, right? And so what I'm going to say is, first let me add a space there. I'm going to say that while x is greater than 0, I want to add to the output. And so I'm going to say multiply the output by 10, and then I'm going to add the modulus of x, and I'm going to divide x by 10. So what is this doing? What this is doing is, if we look at the number 123, what this is going to do is if we're starting off with 123, our output in this case is 0. So we're going to multiply the output by 0, and so output is 0 at this point. Our modulus is, it returns the remainder of the number we're dividing by. So 123 divided by 10 would yield 12.3. The remainder would be 3. And so the modulus operator is going to return that remainder. And so now our x modulus 10, which in this case our x is 123, is going to return the 3. And so now what we're going to do, we're going to add those two together. We're going to add the 0 and the 3, and so now our output is a 3. And the next time we come around the next iteration, our output will be equal to the 3. Our x is equal to, since we did 123 divided by 10, it's just going to return 12, because it just ignores the remainder. And so these are our inputs. These are our inputs right now. And so now what's going to happen? We're going to multiply our output by 10, so we get 30. And then our 12 modulo 10, our x modulo 10, which in this case x is 12, will be 2, since 12 divided by 10 is 2. No, 12 modulo 10 is 2, because there's a sorry about that. 12 divided by 10 is 1.2, with the remainder of 2. And so, like I said before, it's going to return the remainder, which is 2. And so then we're just going to add the two numbers together. 30 plus 2 is equal to 32. So what happens in this case is we keep multiplying our output by 10, so we move it one digit over, and then we add the modulus so that we, I suppose, add a number in the ones place. So we keep moving our number over and then keep adding in the ones place. And so let me I'll remove the output here because I think you can tell the output over here is 3. And then at the very end, at this point, since 12 divided by 10 in Python is going to be 1 because it just ignores the remainder, x is going to be 1. Our output is already 32. So we're going to do our output, we're going to multiply our output times 10, and that's going to be 320. Our x modulo 10 is going to be 1, since 1 divided by 10, the remainder is 1. And then we're just going to add them up. We're going to do 320 plus 1 is equal to 321. And so this is our output right now. And then after this, 1 divided by 10 in Python is going to be 0, since no remainder. And so when we check our while loop up here, 0 is not greater than 0, so we're just going to exit the while loop there. And so that's kind of the idea behind multiplying by 10 and then adding the modulus remainder. And then obviously to decrease the number, we have to keep dividing. And then at the very end, what we want to do is, at this point, we've reversed our number, but we need to make sure that if the number was negative before, that we handle for that. And so we'll say if is negative, return -1 times 30 times not 32 times the output. Else, we're just going to return the output. We're just going to return the output. One thing we do want to handle for is over here they said the numbers have to be within this range. And so what I'm going to say is if is negative, first I'm going to check to see if sorry about that, if output is greater than 2 to the power of 31. That's how you do power in Python. You can do this these two stars, asterisks, return 0. So what this is going to do is, this is the most, I suppose, the most negative our number can be. And so before multiplying our number by -1, again, we are just going to be seeing if our positive version of the negative number is greater than 2 to the power of 31. And if it isn't, we're just going to return our -1 times the input. And if it is, they say that we should return 0 if it is bigger than this number. And then for the positive version, we're just going to check. That's weird. Let me see if I can create some space here. So that we can see the bottom. I'm going to return this, delete this first line also, since I don't think we need that. Else, if output is greater than 2 to the power of 31 minus 1, I'm just going to put some parentheses around here to make it easier. Return 0. Else, we're going to return the output. So in both cases, the biggest positive number we can get is this. So we're just checking to make sure our number isn't bigger than that. If our number was originally positive, which means our is negative was false. And so yeah, if that is the case, we return 0. If not, we're just going to return our output. And so now what I'm going to do, I'm just going to code this up in our editor here. Is negative is false, x times equals 10, else is negative is equal to true. After that, what we want to do, while x is greater than 0, we need to first create an output variable. While x is greater than 0, x divided by 10, and I believe that was it for that. If is negative, no. If output is greater than 2 to the power 31, return 0, or else we're just going to return our output times -1. Hopefully we have that, yeah. Else, we're going to check if our output is greater than 2 to the power of 31 minus 1. If that is the case, we're going to return 0. Else, we're going to return our output. So a couple of these examples are already here. Let's just run them to make sure that our function works. This should be true. I have this backwards. False. That should return the right number. Let's run this. Output 0. Interesting. First, let's run this to make sure this works, and then we'll look at what the problem was in our 2 to the power of 31. Okay, so we run that right. So we're returning an output of 0. If is negative. Oh, it's because we have to multiply by -1. Did I? That's weird. Okay, so we got that right. I think Leetcode on its own is going to test this statement right here, so hopefully it works when we get along to it. Actually, what I'll do is I'm just going to write a really huge number. And hopefully this works. Okay, let's just let's just submit, and then hopefully I think Leetcode will just test the case for us. So yeah, I'm not good at that. I wasn't good at that thing. So yeah, it looks like our program is working, and this is how you can reverse an integer on the Leetcode problem. Hopefully this helps you guys, and see you guys in the next one. All right, later.